So with that, I think it's time to talk about the future. I'm hoping that some of you saw V19 today, you saw Bricsys BIM yesterday, you saw Bricsys Mechanical today. You're probably thinking, wow, the future's here already, but wait, there's more. If there's anything that this company is famous for, and if there's anything that I've really still, after a year and a half here, pretty much in awe of, is not only the speed of development at Bricsys, but also the thought process that goes into creating new features. Not just fulfilling customer wishes, although we do that every day, but thinking about the customer's needs at a different level and bringing them features and technologies that they didn't expect, solving their problems in a different way. So with that, I'd like to invite Tjerk to the stage and ask him to talk to you about the next generation of features that will be coming from Bricsys over the next year and beyond. Tjerk.
Good evening. I know I come at the end of a very long 2 days, packed with all new features and all live demos. And I am here to give you kind of a snapshot of what future Bricsys releases could look like. And I have one big main disadvantage, and that is that I don't have live demos, because it doesn't exist yet. I'm also not just going to give a big list of that's going to be in the next release, and that is going to be in 2 years in the release, because while we have some ideas for the next releases, those lists are not yet fixed. Because innovation, it starts to come up mostly from the ground up. It goes very organically in our company. We talk a lot with each other. Everyone is involved. People just coming from college, all managers, all coordinations, even salespeoples. We all brainstorm along a lot at the coffee machine. It's not always in meeting rooms. And very organically, we try to shape and try to address the real research questions. So what I'm then going to do today is actually show you the main research questions that we have been focused on for these past 2, 3, 4, and so on years. But especially, the talk is mostly going to focus more onto the BIM questions, because that's where we put most of the innovation in the last years. But you will see that most of these things we try to broaden them up to make them for the full CAD package. Of course, a talk about future technologies cannot be without one main topic that we need to address. And certainly in the CAD world, it's often a big elephant in the room. This is artificial intelligence. Why do I say it's a big elephant in CAD world? Is because for a CAD product, it's not so clear what an artificially intelligent CAD product could look like. If you have to design or if you're creating a self-driving car, it's pretty clear what your artificial intelligence needs to do. Stick to the road, don't hit passengers, and so on. Also, the most applications of artificial intelligence these days are the ones you already see, both in your personal and your professional lives. They are typically very specific. They are about recognizing people on pictures, recognizing speech, recommend you some friends on your social network, and so on. But the question is, what would it really mean to create an intelligent CAD system? So before I go into these research questions I was telling before, let me first try to sketch out how it could look like. Well, there are actually 2 ways to think about this. And when in the CAD world, people talk about artificial intelligence, they typically refer to generative design. It's very fancy these days in academic circles. And you also see some of our competitors taking some small steps in that direction. For instance, one of those competitors created a prototype who automatically designed a quadcopter, so a flying drone. Another competitor included a module in their product to generate automatically stairs, which is based on artificial intelligence. But these are very limited applications. You can easily call them still prototype stage. What would it really mean? Does it really mean that the future of CAD is that you have software, whether it be on the cloud or on your desktop installed, that just designs whatever you need? If you think about this, people draw back a little and they become a little bit white and pale, and because that's not really what people would love that it would look like. That's HAL 9000 from the movie, for those who haven't recognized him. So this is the subjective feeling. Of course, if it would change the industries, and if it was feasible to create such a fully artificial agent, creative agent, it will probably come there. But there are also some reason to suspect that such a scenario is not really for the upcoming years or maybe even decades. Because, as I've told before, applications you find these days in real life already. So intelligent applications that you use in your personal or professional life, these have a very specific goal. They're very single purposed. They need to recognize people on pictures, or they need to be able to transliterate some speech into written text, or they need to recommend you a good movie for tonight. A bit more ambitious is they create self-driving cars and robots in manufacturing. But you see the trend? It's always a very clear single goal, and that algorithm is specifically trained to do exactly that. And even is the goal not very clear, like for instance those recommendation systems, then there is a very clear way to give feedback whether what it is presenting, for instance, if you get a recommendation for a movie tonight, well, you like it or you don't like it. And giving that feedback, the algorithm can easily train itself further to improve, and it will improve in giving you better recommendations. But can you imagine this for a CAD or a BIM software? So it just generates kind of building, and then you say, yes, I like this, or no, I don't like this. That's not really helpful, right? Because what you actually do in a design stage is you're thinking with concepts, you're playing with volumes, with ideas, and you need to be able to, at least if something is proposed to you that is automatically generated, to give high-level feedback. You should be able to say things like, I maybe like the idea, but the overall shape is not good, or I want a larger entrance hall, or these walls have, yeah. So at least at a high level, you need kind of a way to communicate with this algorithm. And if you just train it, and you just give it a bunch of models, and it only has learned to generate these models for you, there is no such language, because algorithms think and work very differently than humans do. So you will not be able to give feedback, and you will really get stuck to, I like it or I don't like it. So that's why a more realistic goal to set forth, and for the next decade or something, is to talk about an intelligent collaboration between a designer and a machine, a team of man and machine. Why? Because each of them is very good in certain tasks. And if you think about it, people and machines are pretty compatible, because they're good at things that the other thing is pretty bad at. yeah, you see a list here. I'm not going to just read the list. Maybe it's interesting just to tell how such a collaboration could look like. It starts, of course, with the designer. Whether he's working for himself or for a client, it doesn't matter. But he has some design goals. He has identified some of the design goals that needs to be in this design. Typically, if you have some design goals, you have also some initial ideas, so you want to prototype them. If you have no inspiration, you can always use these generative design tools, because I didn't say they are not handy. You can use them as inspiration just to get some initial thing, but you need to keep on building on them. So either the human or the machine generates some initial ideas. At that point, once you have a prototype, then the computer is very good in getting the details done. That's what we focused a lot on. Eric mentioned it yesterday in his opening address. Details, God is in the details. So you need to get the details ready, and if there are thousands in buildings, especially, there are thousands of details, but in this excavator there were also quite a lot. You need some help to get all those details good. Of course, once you get into a detailed model, it's not finished there. You start to have a look of your design, you want to change it. There, you need to be able to give constructive feedback. And I put the constructive there just to say that it's not about saying like, I like your ideas or I don't like your ideas. And also, typically, humans need to be in charge of the overall aesthetics of this project. But what computers then can really help is, once the design is there, is getting all the design documentation for you, because that's part of the repetitive tasks that computers are very good in. Also, you have identified some design goals. If you need a building with that X square meter of office space, you can put that up front. But once you get into the details and once you think about style things like, I want a nicer, fancier entrance hall, you might lose out of sight that you need to have that amount of square meter of office space. And the machine is very good to run in the background and check whether you still have all your design requirements there. The last one that I want to talk about, and actually I was thinking that I should have put it on a different slide because it's an interesting point, is innovation lead. Why? Suppose you train an artificial generative modeler with a whole bunch of Baroque architectural models. What would you think that the designs that come out of such a machine would look like? Well, they would just be more Baroque. So how can you get then into neoclassicist era? I know computers can also kind of try out new ways, but let me tell you a trick of the trade. If computers need to explore into new eras, you just have to do it by adding some randomness in the algorithm. And if you put some randomness in it, the computer can innovate by itself if it has a clear thing that it needs to maximize. For instance, I was telling about a design for a quadcopter, kind of drone. Well, there you need to minimize really on the weight of that while still ensuring the overall stability of this design. So there is a very clear indication that can be calculated to see whether such random explorations are actually useful. But in design, often the criterion is the overall aesthetics. So it's up to the human to decide whether these new arrays and new ways of innovating are good. That's why the designer is still needed there. So before I go into some further details about what we're going to be up to, so I sketched kind of an ideal collaboration between a man and a machine. So what to expect if you want to, of such a machine, if you want to collaborate with it? In fact, you expect of it the exact same things that you would expect of a human with which you want to collaborate. You want him or her to be very reliable in their part of their job. It's so that you can trust them. For the machine, we can take care of that with AI and a lot of other algorithms. But what is also important, and this is, I think, the main message of my address today, is that you need to build also on a common understanding of the project. It means that you need to train the computer to have a high-level shared semantics so that you can communicate with your computer about high-level things such as connections or overall space and feeling and light. And in order to be able to have this shared semantics and use it and collaborate it in a very quick back and forth collaboration, therefore you also need to work on intuitive interfaces because it needs to go quickly back and forth. So these three things are they will come back in the more specific questions that I will address. So let's go now look at the questions that we have really investigated in the past 2 years, and then you will understand how all these innovations you have seen can continue in the future. So the first question is about, can we let designers prototype in real time? It's very ambitious, but I think it's really important that, and I already stressed this yesterday in the BIM demo, is that designers should be able to prototype almost as fast as they can do with pen and paper, because you're thinking through designing. That's why we started thinking about how can we model buildings. QuickDraw is our first step into that direction. Of course, this is just like a first version of this tool. It's only limited to rectangular and L-shaped rooms and volumes. So you already see how we need to expand this. But prototyping is not only for your initial design, it's also that once you have a design that can be very detailed, you still need to be able to do high-level modifications. And the model needs to understand how it needs to react. So the machine really needs to have an understanding of what are the connected elements and how should I preserve them, so that if you drag on certain places, that everything moves as if you would expect it. So these are some of the tools that we presented in the V19. But you can already see what's going to be the future of this in the next versions. Namely, that we're just going to keep on continuing these. So, as this quick draw tool, it could only draw rectangular and L-shaped rooms, all of the same height. So it's clear that we need to work there on tools to give a little bit variation in heights, to allow to add stairs, elevator shafts, entrance halls, really treating the volumes, the big volumes of your designs as the initial and main components of your design. Also, you saw this connected dragging. We need this understanding of connections be in all our direct modeling tools. For instance, if you rotate a little bit the facade, that everything stays nicely connected. The next question is coming back to the details, because that's about the computer needing to do their part of the job, which is very time-saving. Yes. So, can we let designers create 3D models with a fine grain of detail? Well, we've already talked a lot about this, that detailing work involves a lot of repetition. And if you look at how other people try to solve it, well, you could grind it manually, but then you end up like the stick figure. there are tools like copy and array, and of course sometimes that's just what you need. But what's the problem with just copying details is that details are connected to their local environment. They are not isolated objects. They can be small modifications to some solids. Also, what's happening a lot is you only do the main contours in 3D, then you generate your 2D plans, and then you add all the little circles with all the details, how it should be worked out. That might work until you get some problem with a clash or an interference. That's why yesterday in the BIM demo that we showed the example where the structural file and the HVAC file were together inserted in the model, and it had as a result a big interference which you need to solve. If you only work on the 2D, there's a chance that you only will see it at the construction site. What most competitors do is they create a bunch of templates, but if you're only having templates, then it prevents free modeling, because it's not so easy to add extra templates to generate more details. And you certainly don't have then the direct modeling tools. So our solution, you have seen it, is the Propagate tool. And what Propagate actually does, we really reworked it so that it worked with modeling details, we call them. They are detail volumes. That means just we carve a volume out in 3D space, and we analyze how this detail is connected to the environment and specify the boundary conditions on it. That are those purple shapes you see always on those volumes. Of course, details come in many types. It's not only this kind of detail, and that's about our approach. It's fully generic. So it doesn't matter whether your detail is a window, a connection between walls and slabs, a structural connection, an HVAC connection, a roof cap, a wall cap, a railing. It actually doesn't matter. It's the same mechanism of carving out a volume in 3D space, analyzing how it's connected to the environment, and then you can propagate it to the other things. So that's how we solved this problem so far. But that's not where we should stop. You can go further with this, because these details, you can really start to treat them as independent, standalone entities. What do I mean by this? Well, you could allow some further direct modeling on them. So now the command automatically detects this volume. But what if you just want a little bit of a bigger volume carved out of space? You can add some push-pull to it. Or it propagates it nicely into all kinds of patterns of windows. But what if this single window just need to place a little bit different? Then we can add some dragging and moving at the target locations, because rotations is what's next on the list. Just the same as dragging, of course. And sometimes you need a little bit of scaling. Actually, you already see it coming. What you really want is to parameterize those things. For instance, you see here that this member is connected to this column by an angle. Well, why not automatically detect that this is an angle, generate a parameter for it, and then you can copy this detail also to places where this brace is in a different angle. And once you get to these parametric details, you can start storing them, generate libraries, and use machine learning on them. Now, at this point, I have a little message for third-party developers, because they might think like, oh, is Bricsys really going all into these domain-specific areas? Well, this is pure geometry. We don't know what this is. I see there a few plates and a bolt in that volume, and that's all that I know of this structural connection. I don't know what a good structural connection is. That's what third-party developers could do, because we can build an API on top of our propagation tool, and then everything you saw us doing, you could just use in your own application, and you can generate the libraries with the parametric details and let us solve the geometry so that the final model is a fully or a complete 3D representation of how it should look, fully detailed. So don't see this as a threat, but as an opportunity to just let us do the geometry for you. Next question. Come back to parameters. And parameters and constraints, these are actually a solution to a very important problem. This is that if we humans design something, we don't see just that geometry. So this is a very stupid chair. It's not that hard to model it. It's just a prototype. But for the computer, this is a bunch of faces, edges, some geometry, some coordinates, and that's it. But for humans, you see a chair with a chair height, a seat height, a leg width, and for us humans, we see it possible that you kind of vary all these things. We see the functions in those aspects. And that's what I was talking about, that we need to create a shared semantics with the computer. The computer has to learn to see this chair as we see it. So that's why it needs to be able to parameterize it, to find the driving parameters of this chair or any other design, and allow to have have this meaningful feedback and communication with the human going on. Okay, that's what we had today. That's what we presented in the V19 that will be released in a few weeks. But there's no need to stop there, of course, because it's very important to understand this shared semantics, these driving parameters, and this functionality of the various aspects of the geometry. So far, parameterize only work for a single component. We will continue to work so that we also can detect parametric arrays. This sounds as a logical continuation. But we don't need to stop there. We can also go further and go to entities that do not yet exist, but these detail volumes, we also want to parameterize them. And even, so far it was only 3D. You know, there's a competitor who has a tool, it's called Dynamic Blocks. And it's apparently often used because it solves this problem that you need to be able to specify various alternatives of a single design. But it's a lot of manual work to specify all those alternatives. That's why if we could now just move our parameterizing tool from 3D to 2D, then we can provide an alternative for this which has a much more intuitive interface. So that's something we will work on for the V20. A few more research questions left. And one that's typically for BIM is, we focused on the geometry design. Also with a more intelligent computer, it will be needed to just focus on geometry, design, create your building, and don't be bothered with BIM data, which compositions, which classifications, etc., etc. Our process to add this BIM data afterwards is a BIMification with the BIMify command. And you've seen yesterday that we have extended the BIMify command with yet another bunch of features. In fact, 2 years ago on the conference, I don't know how many of you were there, but then we announced that we would kind of give this workflow or create this workflow that you start from geometry, and it could be imported geometry, and that we could add the BIM data afterwards with means of artificial intelligence and other algorithms. Instead, currently, most of what has been said there is now in the V19 product. There was only one slide left that was then maybe a faraway dream, but sounds now like a concrete development idea for the next year. This is the idea of a BIM style. So what's a BIM style? Well, that's BIM data, but connected to high-level concepts of where to apply it. So in a style, a building has certain materials, and then you ask, where are these materials applied? Well, then you could say that we have a material for the external walls, we have one for the internal walls. Oh, we have a room that has some extra acoustic isolation, so there's a different material there, and there needs to be a rain coating at the south side. So this is, in high-level concepts, you describe how you should apply a set of data. It's not only materials, you can have the same for connections, you can have the same for door and window styles. So it's again, we're coming back to the computer needs to learn to understand what are the high-level functional parts of a building so that you can list a bunch of BIM data and just apply it intelligently to your model. And then you can also work on tools to detect the style of a model, apply it to another model, or detect the style that you've started to use and just complete your model in that style, so that adding of this BIM data becomes a lot more simpler afterwards. Question that often comes back is that people apparently always start over when they have to switch from design, or if design has to be handed over from one role to another role. So we really want to work on ways to increase the interoperability of your designs so that you can easily transfer them from one way to another way. The first thing is, well, you saw Blockify this morning. If you get these huge files coming in, and this is really about performance, you need to be able to work with them. That's why we created Blockify. It reduces these huge files that might come from a step source or something with factor 10 and more. But Blockify currently, well, it does a lot because it reduces them with that factor, but it's not yet finished actually. We need to keep on working with it because currently we only detect which solids are equal in very fast time, but we also need to detect where the structure, how the different solids relate to each other, so that we can also build more high-level blocks of related components and assemblies, so that we can detect assemblies in a model. Also, a problem often with incoming geometry is tessellations. It really becomes time that we try to understand that, for instance, you see those elbows there. That shouldn't be triangles, but just a curved cylinder. That we can detect it and replace the geometry. It will make the file sizes smaller. It will make Bricsys working faster on them. And actually, it will also improve our intelligence that can understand what the connections are in a model. So all these commands that you have in Bricsys will work better after you have removed the tessellations. We've shown that we have added point clouds into Bricsys. What's next is also detecting the geometry in there, so that also here you can speak of certain forms of simplification. And this has already also been mentioned in the, oh, I have to click 3 times here. Has mentioned in the BIM demo, so I won't go in depth on this, but of course all the open BIM collaboration formats, we will make sure that we are compliant with them. Oh, final thing, this is an interesting one, because if you have it right, I don't think there is a good solution currently on the market, that if you have a geometric design of a structural design, to automatically detect and export the analytical model for it into a strength calculation program. We hear from structural engineers that they typically have to restart over. But with our current understanding of how connections are in the model, how the connections are related to each other in the model, We think that we currently have laid the framework to be able to export an analytical model for a structural design automatically. So that's something we will work on for the V20. Last thing I want to address is, you know that big BIM projects, they really become huge. And it's sometimes very hard to find your way in there. Actually, if there's more than 10,000 solids, building elements, etc., how can you ever find, if you're looking for just the small walls in your project? It's very hard. So we're already busy with a project to be able that you can query a BIM model just as a database, a bit SQL-like for people knowing this, where you can combine all BIM data with all geometry information of the DWG. It's not yet in the product, but what we have put in the product is, you see in the structure browser, which is a lot used, there's a little search box on top. You can search there literally for names, of course, but you can also already type small formula in there. And if I want to select all small walls or very thin walls, I can do it this way right now in V19. But this is, of course, just like a small preview of what we're actually aiming. So we need to be able to just find any high-level concept directly in your BIM model. For instance, you want to have, in a large model, directly selected all rooms which don't have sufficient light, or all rooms which the designer forgot to add a door, and so on and so on. That's when we come to the question of requirements. Typically, you have design requirements up front. We are working on a way to write them down in a codified way so that during your modeling and during all your design stages, going from prototyping to adding initial details to changing your initial design to redoing the details, adding the structure, adding the HVAC, etc., that the computer can always do the requirement checking for you. And it's not only for your own requirements. You can think of, there are standards to comply with, building standards, ecological standards. And once you have a language to specify those standards, we can start on creating these requirements files up front, and then can be automatically checked. So that's also an ongoing project where we want to show you some more in next year. So I will finish up now. And actually, you know, in the beginning, I was specifying 3 criteria that you really would expect of an intelligent collaborator. We're not yet there at that stage. That will take a few more years. But I think that the steps we're going for in the next few years are the right steps to get to that intelligent collaborator in a few years. So we need to work on delegating more stuff to the computer. All the kind of repetitious stuff that can be done by the computer needs to be done by the computer. We need to work on a shared semantics so that the computer understands your model in the same way as you do it, at the same high-level concepts. And you can see our efforts on parameterization and BIMification, keeping connections all in that context. Finally, if we have to keep on working on making the interfaces as intuitive and as direct as possible, to adding tools for prototyping, adding menus, put them as contextual as possible. Also our efforts in virtual reality, you can see all under that denominator. So I'll add with actually the baseline of Bricsys because I like it. And it's because it states that the focus needs to be to give designers their creativity. And to let them be creative, we need to make the computer do all the other stuff. Thank you.
So, this, if you see me here now, it means that I'm the last speaker, so somebody has to say the final word. Before I start this, I got a message for you that I received from Don. There is, as you know, there is an after party. It's called the legendary Bricsys party. And it is in the Café de Paris, 3 to 4. It's in Coventry Street in London. And it starts at 7:30. So we strongly advise everybody to be there. I mean, you know, you can't miss that. I mean, it's really a rock and roll, wild party, so you're gonna love it. So this is the closing, and you know, there must be a conclusion, and the conclusion is how will we win. But before I start that, I think after all what you have seen, I was a bit surprised to see in some press that is covering us and in this conference, you know, they still refer to us as a clone. I think it's a bit unfair after what we have shown. And to my perception, a clone is something that tries to be identical to the original. So I think that is not really applicable to us anymore. Let's keep the term clone for the others that are, I think, trying indeed to be identical. And I would appreciate if in the future, you know, because we are ambitious. We want to take, you know, the market by storm. So I would appreciate if you in the future would refer to us as a cyclone. I don't know. I think it's a very good one. Right? Thank you. Thank you. So how will we win? As I said, you know, we want to stress that 2D, you know, still is extremely important. It's not because we are, you know, moving the edges and the bar for 3D that 2D goes away. Absolutely not. I mean, and it is very important, and we're gonna, all the things that we are making for 3D, if we can make it applicable, some parts of that, and I'm talking about artificial intelligence, etc., we're gonna apply that to 2D as well. So speed up that process, make that intelligent. So that's really, really important for us. Performance, stability, also on the GUI. You know, yesterday when I started the conference, I have referred to asking you watch that BIM demo, and you know, if you recognize the normal, you know, lot of dialog boxes and the thousands of icons, I hope you saw that and that you really, you know, realize that it can be different, but it should be different all over the place as well for 2D. Again, we confirm that we're gonna keep the old standards, the old GUIs as well available for everybody who is used to that. But the younger generation, we really doubt that they will be willing, you know, continuously within 5 years and 10 years, you know, to work like that. You know, hardly believable. 3D direct modeling and 3D constraints. This is, you know, the basic technologies that we have started in 2011 when we acquired that technology from our Letters friends, and you know, was developed by a lot of guys that are in the room and gave that mechanical presentation. So it's extremely good, but that will improve workflows overall. I mean, we're gonna really misuse that. I mean, that's so good technology. And you have seen some examples of that, so we're going to continue with that. So 24/7 SaaS application. What you see in the future is really more and more integration from what you have on a desktop, and at the side you have a real-time contact, you know, with what's happening in the cloud, synchronizing. You know, we're going to improve that. So there's a lot of stuff to do there. Today we have that for BIM collaboration. And we are, you know, sure if we are moving into the mechanical part more and more, that exactly the same mechanics can be used for PLM and PDM. I mean, when it comes to really connecting data to geometry and then manage things, we can do that as well. So, artificial intelligence. I think after the presentation of Tjerk, I don't have to, you know, add much to that. I think you understand that this is going to be a pilot for us for the next 5 to 10 years. So important. I think we are, in the forefront of what can be done with artificial intelligence for geometry and for CAD in general, the engineering in general. But of course, we're gonna, bet hard on what we have already and extend that. What we didn't show here on stage is vertical reality, AR and MR. It's almost for unlimited project size that we can do it now, that we can use it now. We had it presented here for the last couple of days in one of the rooms close to where the coffee was. But don't underestimate what we can do with that. And we see that it's going to be very useful for really large projects, especially in the plant design, we think. And we are able to really calculate or prepare for virtual reality the largest projects in the world. We can do that. So we are expecting a lot from that. Connection with others. Then I think, first of all, at the ODA. The ODA has evolved from its first decade being the kind of reverse engineering institute to reverse engineer only DWG. For the last 3-4 years, we see tremendous steps forwards, and I'm really thankful for Neil to pin that out today as well, and I must thank him for a wonderful job, becoming CEO of the ODA and bring that forward. We are a big contributor, that's true, but we are also a big user, so we should be thankful as well for it. It's really, really good. And today we have seen, or yesterday we have seen the implementation of RFI made by them. Work in progress, Navisworks, and we are still expecting a lot more of file formats that will contribute to disclose really proprietary formats. And it's not that commercial products cannot use it then, but they should be open. In the name of and for the sake of collaboration, it is needed that those kind of things get open. And so that's really a big task, but a great job for the ODA. Also, connection with others. We have our own Communicator. We are supporting 13 file formats, and we are extending there as well. It started with geometry, then styles. We're going to add data as well to that. So that Communicator becomes really a center point if you want to talk to all the other mechanical parts as well. Of course, there is IFC for BIM. We are expecting that IFC is working on civil and infra. That becomes as important as what it is for BIM. And of course, we can only repeat it. All these things we do, it's on one file format in one platform, .dwg. We are absolutely convinced that we can give that really its second generation. It's now 36 years out there. I think by now you see that it is absolutely not a limit. I always refer to the Mac. The Mac is, famous for its interface, but it's Unix. It doesn't matter what is underneath. It's about what you're doing with it. That's exactly that same paradigm. That is what we are using for .dwg. And how we will win? Finally, one .dwg platform, but of course, we expect a huge boost from what we have announced, with our friends with Hexagon. There, in the areas where we were weak, and we are, modest enough to know that and to confess that, in the areas where we were weak, that was marketing and sales. If we have to speed up that at the level to have an impact in the market, that would be really very, very difficult. So we are convinced and very confident that with the acquisition of Hexagon, buying us, that will help us a lot. And I guess it will help Hexagon as well, and otherwise, they would not have done it, I suppose. And then finally, there's something that I have to say. I have not a slide that is big enough for that. First of all, I confirm again that I absolutely stay, in the company and in the community. I'm not leaving, but it is a milestone. So I mean, it's time to say to the team, we have worked for 16 years on tremendous things. We're gonna continue to that, but I have to thank, the whole team for daring every day to rethink all the things. You know, not being scared to start from scratch, and we're gonna continue with that. And I don't want to make this a kind of Oscar speech, but it has not always been easy. Those 7 that started in 2002, they know that in the beginning it was hard. So I have to thank as well my wife and my kids, because they really had an unconditional support for me in my darkest hours, and I thank them for that. Thank you very, very much for being here. Thank you.